Okay, now let's read through this one together. It says, if the probability of one event occurring changes the probability of a second event occurring, then these compound events are called dependent. You've done something kind of like that in science, dependent variables and independent variables, okay? Two events are independent if the occurrence of one does not affect the occurrence of the other. All right, let's do this. Carson, let's say I've got a bag full of marbles, not full of marbles, okay? I've got, man, that looks like someone's stomach. All right. I've got a bag full of marbles. I'm losing my marble. Okay, there's a bag. Okay, fine. 2 blue, 1 red, 1 green. Okay? Now, Carson, what is the probability that I'll choose a blue?
Half.
2 out of 4, right? Is that right?
Yeah.
2 out of 4. Now, I would reduce that and say 1/2, but let me ask you this. What if I keep it? I pull a blue out and I keep it. Now, what's the probability that I choose a green?
1/2.
How many are green?
1.
And how many are in the bag?
What if you took the...
I took 1 out.
Oh. So 1/3?
Okay. Do you see how the first one changed the probability of the second one? Do you see what I'm saying? Because what would the probability of choosing a green been at the very beginning? Anson. 1 out of 4. But since I chose 1 already and I pulled it out, now it's 1 out of 3. Do you see how these are dependent on each other? The second one's dependent on the first one. Now let me ask you this. What if I roll the die? What are the odds that I'm going to land on a 2? Annabelle? 1 out of 6. Now if I roll the dice again, or the die again, does it change the probability of me rolling a 3, Ian? No. Rolling a die is independent. It doesn't matter what happened before it, right? So those two events are independent. Now let's look at this example that they gave us. All right, this will help us understand a little bit more. You put 6 red marbles and 2 blue marbles in a bag. All right, here's the bag. I'm better at drawing this kind of bag, I guess. It's a paper bag. Okay, and inside that paper bag, you can't see it, but there are 6 red and there are 2 blue. Okay? You draw 2 marbles from the bag. What is the probability of choosing a red marble and then a blue marble if the first marble is replaced before the second marble is chosen? That's A. Matt. That means when I pull this first one, I'm going to put it back in. Okay? What's the probability of choosing a red?
Choosing a red would be 1/8. Or no, 6/8.
6/8. Okay? Now I'm going to put it back in. What's the probability of now choosing a blue? 2/8. Right? And you know what? If I want to know the probability of 2 things happening, I've multiplied their probabilities. What would the probability of choosing a red and then choosing a blue be? It's the probability of choosing a red times the probability of choosing a blue. What is that, Carter?
Well, the non-reduced version would be 12/64.
12/64. And what's the reduced version?
The reduced version is
3/16. Now let me ask you something. This first one, was it independent or was it dependent? What do you think, Cara? Did the second one change probability based on the first one? It didn't. So we'd say it's independent because we put the marble back in. Let's see what happens in the next one, and I'm going to have to go to the next video for that one, all right?